Hello everyone, I am Santhi from Department of Mathematics and Statistics, Bhavan Vivekananda College, and here I am with lesson 7 from linear algebra on vector spaces. In this lesson, I am going to explain the following concepts. The first one is linear combination of vectors and the second one is linear span of vectors. Let me show you some examples. Suppose I have a vector u1 is equal to 1 minus 2 and I have another vector u2 is equal to minus 2 and 3 suppose. Then we know that if I multiply the vector u1 with suppose 3u1, what will be 3u1? It will be 3 and minus 6, and what is suppose 5u2. So this is 5 minus 2 is minus 10 and 15. These are also vectors, and we also know that we can add 3u1 and 5u2. So that will give you 3 minus 10, which is minus 7 and 9. So what do you call this as? You are writing a combination of vectors u1 and u2 by using some scalars 3 and 5. So what is the result here? It is again a vector. Similarly, with the same u1 and u2, suppose I use some other scalars. Instead 3, I use the scalar 4u1, and instead 5, I use the scalar minus 1u2. So then I'll get 4 into 3, 1 minus 2, and then minus 1 into minus 2, 3. This will be also 4 plus 2, which is 6, and then minus 8, minus 3. So which will be 6 minus 11. This is also a vector, another vector. That means like this, with the same u1 and u2, you can make infinitely many combinations. So these combinations, we call them as linear combinations of vectors u1 and u2. So now let us see the definition of linear combination. Suppose I take a vector space V, consider a vector space V, and let u1, u2 and so on un be vectors in V. Then for scalars a1, a2 and so on an, the expression of the form a1 u1 plus a2 u2 plus and so on an un. This is called a linear combination of u1, u2 and so on un. This is the definition of linear combination. Now let us write some important points on this linear combination. The first point is any linear combination of given vectors in a vector space is again a vector in the same vector space. So this means here I have already showed you some example. I have taken u1 and u2. Where are these vectors? Belong to suppose R2. Then a linear combination I have written 3u1 plus 5u2. What did we get the answer? Minus 7, 9. This is also belonging to R2. The same. Another linear combination we have written, we got it as minus 6 and minus 11. This also belong to R2. That means any linear combination of vectors is again a vector in the same vector space, that is a1 u1 plus a2 u2 plus and so on plus an un. It again belongs to the same vector space. V. Right. Now let us come to the second point on linear combination. For any given vector B and a set of vectors u1, u2 and so on un in the vector space, in a vector space V, if we can find scalars a1, a2 and so on an such that B is equal to, that means the vector B, if it can be written as a1 u1 plus a2 u2 plus and so on an un. That means you are given a vector B and you are given another set of vectors u1 to un. If this vector B can be written as a linear combination, if you can write this, if there exist scalars a1, a2 and so on an, to write B is equal to a1 u1 plus a2 u2 and so on plus an un, then we say that B is a linear combination of u1, u2 and so on un. Now let us see how do we determine whether B is a linear combination or not. Let me take one example. Suppose I have taken a vector B is equal to 2 and 3 and I have taken vectors u1 is equal to 1 0 and u2 is equal to 0 1, then I can write 2 3 as 2 into 1 0 plus 3 into 0 1. You can check it. 2 ones 2 and plus and then 0 and here 3 0 0. You can write this 2 plus 0 0 plus 3, which is nothing but 2 3, right? That means I could write B as a linear combination of u1 and u2. Fine. This is very easy to find. Suppose the same B I will take and I'll take some other vectors. u1 is 1 by 1 2 and u2 is equal to some 3 0. Now can we try to do it? Suppose 2 3 is equal to some scalar into 1 2 plus some other scalar into 3 0. Is it easy for you to check here randomly what do you get scalars? Here if you observe in the above one, since these are 1 0 0 1 like unit vectors, it is very easy to once 2 here we will get here. The second one you made is 0 and say this is 0 1, so 3 times you can multiply very easily. But here how do I? Suppose I try with I try with the 2 here and I put 0 here. What happens? I'll get then 2 plus 0. Okay, fine, 2. But I will get 2 to 4 plus 0. Then I'll get 2, 4 I will get. So I cannot, this is wrong. 2 and 0 I cannot take it. Then how do we have to randomly giving values and checking? This will be difficult and you will take a lot of steps. For this, what do we do is we use a matrix method to determine whether a given vector is a linear combination of a given set of vectors or not. So we have a method here what to determine whether a given vector B is a linear combination. I'll write linear combination as LC of given vectors u1, u2 and so on un. So to explain this also, I'll take the same above example what we have used. B is equal to 2, 3 and u1 is the same 1, 2 and u2 is 3, 0. I'll just assume that let there be like 2, 3 is equal to, I have some scalars, I don't know these, a1 into 1, 2 plus A2 into 3, 0. I will suppose that there are these A1 and A2. Then I have to find now what are these. Then if you write this 2, 3 is equal to, write it as A1 plus A1 and 2A1 plus 3A2 and 0. So which will give you 2, 3 is equal to A1 plus 3A2 and 2A1. What does it mean? I have here some equations. A1 plus 3A2 is equal to 2 and 2A1 is equal to 3. So by writing this expression, I got some equations here. This I'll give first equation and second equation. So here in this, what do we have to find? We have to find the values of A1 and A2. So this we can solve it by writing them as equations. Then here it is very easy, simple. 2 implies I can say A1 is equal to 3 by 2 and substitute in 1 and then you will get A2 is equal to 1 by 6. You can solve and find out. So what did you do here? You solved this system of equations. So this was simple because you had only 2 variables and 2 equations. But suppose I have more number of variables. Suppose I have vector, some vector like this. Another example, let me take b is equal to, I have some 1, 2, 3, 4 and I have u1 as 2, 0, 1, 2 and u2 is equal to some minus 1, 0, 3, 4 and then u3 is equal to 1, 1, 1, 1 randomly. Suppose now I want to check whether this b is a linear combination of u1, u2, u3 or not. Now the same logic if we apply, let b is equal to some a1 u1 plus a2 u2 plus a3 u3, which implies I get here 1, 2, 3, 4 and I don't know these a1, a2 only. I have to find 2, 0, 1, 2 plus and then a2 into, so minus 1, 0, 3, 4 plus a3 into 1, 1, 1, 1. So this will give me 2a1 minus a2 plus a3. Then a1 into 0, 0 plus 0 plus a3 and a1 plus 3a2 plus a3 and 2a2 plus 4, sorry 2a1 plus 4a2 plus a3. So which will give me the equations 2a1 minus a2 plus a3 is equal to 1 and then a3 is equal to 2, a1 plus 3, a2 plus a3 is equal to 3 and then 2a1 plus 4a2 plus a3 is equal to 4. So now you got 4 equations. So we have to solve these 4 equations and we have to find the solution, means we have to find out values a1, a2, a3. Now this is like solving system of equations. In earlier we have learnt using echelon form. To solve this we learned how to use echelon form. So using echelon form we will solve the system of equations. Then when you use echelon form and solve the system of equations, what do you get? You will get the conditions like the system is consistent. What do we mean by consistent? We have written there, it may have a unique solution, it may have infinite solutions. That means this system may have unique solution, means yes, B is a linear combination. So you are asked here whether B is a linear combination of u1, u2, u3. So if you get a unique solution, what do you mean by that? You can find one set of values a1, a2, a3. In that case, yes, B is a linear combination. What do you mean by infinite solutions? this system has infinitely many solutions, that is a1, a2, a3 values, you have infinitely many satisfying this. That means you can write B as a linear combination in infinitely many ways. So in that case also, yes, B is a linear combination of u1, u2, u3. That means if the system is consistent, either you find unique solution or infinite solutions, then you will say that B is a linear combination of given vectors. Or if the system is inconsistent, that means no solution. What do you mean by that? By no solution? You cannot find any values a1, a2, a3 satisfying these equations. What does it mean? You cannot write B as a linear combination of u1, u2, u3. So no, B is not a linear combination of B is not a linear combination of a1, a2, a3. Right. Then this also we know in echelon form. How do you determine consistent, inconsistent? You have echelon form, and after solving you have cases. 3 cases. First case, you will get a row in the form 0 is equal to k, if you have remembered. Then no solution. No solution means no, B is not a linear combination of u1, u2, u3. Or unique solution, that means no free variables. Unique solution, yes, B is a linear combination. Similarly, if you have free variable, a free variable is there, then you will say infinite solutions. Then also your answer is yes, B is a linear combination of u1, u2, u3. So this is the way you go how to find, determine whether a given vector B is a linear combination of u1, u2 and u3. Now let us see one problem on this. So the first problem, I am taking the vectors here. Determine whether B is equal to 7 minus 4, 3 is a linear combination of 1 minus 2 minus 5 and 2, 5, 6. So let us take this one as u1 and this as u2. So what do? We go by the same procedure. Let B is equal to a1 u1 plus a2 u2. That implies B is 7 minus 4, 3 is equal to a1 into 1 minus 2 minus 5 plus a2 into 2, 5, 6. So this I'll get the equations a1 plus 2a2 minus 2a1 plus 5a2 minus 5a1 plus 6a2, which will give me the equations a1 plus 2a2 is equal to 7, minus 2a1 plus 5a2 is equal to minus 4, minus 5a1 plus 6a2 is equal to 3. So you need to solve this system of equations, and we know how to solve the system of equations. We'll write the augmented matrix AD. So how will you write? 1, 2, 7, minus 2, 5, minus 4, minus 5, 6, 3. So you can observe this is nothing but take these two matrices u1 and u2. u1 1 minus 2 minus 5 is first column. This is the u1 and this is U2 and this is B. So if B you have to write linear combination of these two, write like this. Then we'll reduce it to echelon form. So how do we reduce? We'll mark the pivot element. So using this, make an R2 and R3 zeros. So we'll apply for R2 2R1 plus R2, and for R3 I will apply 5R1 plus 5R1 plus R3. So I will be getting this matrix is transformed to 1, 2, 7 and 0, 9, 10 and 0, 16 and 38. So this is the pivot position. The next pivot position is this. This we have to change it. So this simply, first, to make it simple, what do I do is, because if this is to make, I have to make this 16 0. So I'll just do this R2 by 9. So that what happens, 1, 2, 7 and this will be 0, 1, 10 by 9. So 0, and even I can more simplify this also, R3 as R3 by 2. So I'll be getting 8 and 19. So that this is pivot and next is this pivot. Using this I have to make the next one 0. This 8 I have to make it 0. So apply for R3 minus 8R2. So I'll be getting 1, 2 and 7, 0, 1, 10 by 9 and then 0, 8 minus 8 is 0, and here I will get 19 minus 80 by 9. So this I will get 19 minus 80 by 9. I am not simplifying this, but this is pivot position, this is pivot position. I can simply mark this, and we remember one thing, we are getting here a row all zeros, and but the last entry is non-zero. So you got a row here 0 0, where 0 is equal to this R3 implies I will get 0 is equal to 19 minus 80 by 9. This is not possible. So you are getting a contradiction here. What does it mean? Implies this system has no solution. What do you mean by that? I cannot find any A1, A2 satisfying this condition. I cannot write 7 minus 4, 3 as a linear combination of these two vectors. That implies no solution, implies no, B is not a linear combination of U1 and U2. Now let us see another problem. We are given vectors U1 is equal to 1 minus 2 0 and U2 is equal to 0 1 2 and U3 is equal to 5 minus 6 8, and then B is given 2 minus 1 6. Now check whether B is a linear combination of U1, U2, U3. This is what we have to check here. Now the same way as in the previous problem, so we will suppose that let B is equal to A1 U1 plus A2 U2 plus A3 U3. So we are supposing that it can be written as a linear combination. What do you mean by that? Is 2 minus 1 6 is equal to A1 into 1 minus 2 0 plus A2 into 0 1 2 plus A3 into 5 minus 6 8. So which implies I'll get the equations 2 is equal to A1 plus A2 into 0 plus 5A3, and then minus 1 is equal to minus 2A1 plus A2 minus 6A3, and then 6 is equal to 0, A1 into 0 plus 2A2 plus 8A3, so which is giving me a system of equations A1 plus 5A3 is equal to 2, and then minus 2A1 plus A2 minus 6A3 is equal to minus 1, 2A2 plus 8A3 is equal to 6. So solving this system is nothing but write the matrix equation and the corresponding augmented matrix we will write. So 1, 0, A2 coefficient is 0, and then 5, and here it is 2, and then next equation minus 2, 1, minus 6, minus 1, and then there is no A1, so here it is 0, 2, 8, and then 6. See this, you can observe straight away. From next problem onwards you can avoid all these steps. Straight away you can write u1, u2, u3 vectors as first 3 columns, and the vector b which you have to like this is u1, u2, u3, and then this is b as the last column in the augmented place you can take. Now we are reducing it to echelon form. So to reduce this to echelon form, so this is here pivot position. Using this I have to make R2 0, minus 2 in R2 position, and in R3 already the first position is 0, so I have to change R2. For R2 I'll do R2 plus 2 times R1. So this will be giving me 1052 and then 0143, and the last one is as it is 0286. So again this is pivot position, first row is over, then the second row pivot position is 1, then using this one we have to make in R3 this 2 0, so I have to change R3. So what do I have to do with R3? R3 plus, sorry not plus, minus 2 times R2. So 2 minus 2 times 1 will be 0. So which will give you 1052, and then 0143, and then 0, 2 minus 2 0, 8 minus 8 0, 6 minus 6 0. So this is pivot position now. This is pivot position now, and there are no more pivot positions. So whatever you got here, this is in the echelon form. So from the echelon form, how do we conclude whether the system has a solution or infinite solutions or no solution? Here there is no chance of no solution because all entries in the last row are zeros. So there is a solution. So how do you identify? How do you identify whether it is unique solution or infinite? This is pivot column C1, C2. These are 3 columns. In the C1 and C2 are pivot columns, which implies, so you can see here the variables are A1, A2, sorry. A1, comma A2 are basic variables, which implies there should be one more variable, A3 is a free variable. So if there is a free variable, what did we learn earlier while solving system of equations? We learned that this system has infinite solutions. What do you mean by that? You can express, you can find infinite sets of values of A1, A2, A3. What do you mean by that? You can write B is equal to A1, U1 plus A2, U2 plus A3, A3 in infinitely many ways. So what do you mean by that? It has infinite solutions implies B is equal to A1, U1 plus A2, U2 plus A3, U3 in infinitely many ways, which implies B is a linear combination of A1, A2, sorry, U1, U2 and U3 vectors. So this is the second one. In the first question we got it has no solution. In the second, so that vector B cannot be linear combination of the given vectors. In the second question you got infinite solutions. So vector B, yes, it can be written as a linear combination of the given vectors. Now let us see third problem, one more. So you are given here B is equal to 4 minus 5, 9, and you are given the vectors as A1, not scalars, vectors as A1 is 101 and A2 is minus 2, 3, 2, and A3 is equal to minus 6, 7, 5, minus 6, 7, 5. So then we will check. So determine B is a linear combination of A1, A2, A3 or not. So this is the question. Now straight away I am not writing, so here all the equations, just I'll write let B is equal to, so I already vectors as A1, A2, A3, so I'll take the scalars as x1 A1 plus x2 A2 plus x3 A3. So straight away I am writing the augmented matrix to solve the system. How do we write augmented matrix? This B should come as the last augmented column. The other columns A1, the first one 101, and then minus 2, 3, 2, and then minus 6, 7, 5, and B is 4 minus 5, 9. So now you have to reduce it to echelon form to determine whether it has infinite or finite or no solution. Right. So now I'll see this is pivot position. So I already here you have 0. You don't need to make any change here. In R3 I have to make R3. I have to make it 0. So R3 minus R1. So this will be transformed to 1 minus 2 minus 6 4 0 3 7 minus 5 minus 1 0 2 plus 2 4 and 5 plus 6 is 11, and then 9 minus 4 is 5. Now I have this, and I have this as pivot position now, second row. Now using this 3 I have to make 4, this 4 as 0. So for R3, so use R3, for R3 using R2 you have to make it 0. So I'll say 3 times R3 minus 4 times R2. So this will be 1 minus 2 minus 6 4 0 3 7 minus 5, and then you will be getting 0 0 5 and 14. So this is pivot position first row, second row I have a pivot position, third row I have a pivot position. Now all the rows pivot positions are completed, so it is reduced to echelon form. Now let us see this matrix. You have here C1, C2, C3 as pivot columns, which implies I have here x1, x2, x3 as basic variables, which implies no free variable. That means this has unique solution, a unique solution. So that means you can write B as x1a1 plus x2a2 plus x3a3 in unique way. So whether you write in unique way or infinitely many ways, you are able to write it. Therefore, we will say B is a linear combination of A1, A2 and A3. Here there is another problem given. Determine from the following whether vector B is a linear combination of the vectors from the columns of the given matrices. So if you see these examples, let us see the first one. Matrix A is given and another column vector or is B is given. Now you have to determine whether this B is a linear combination of columns of A. How many columns are there? 1, 2, 3 columns. So you will proceed as in the same previous problems. There the vectors are given separately u1, u2, u3, and you have determined whether those vectors are linear combination can be written. B can be written as a linear combination of u1, u2, and u3. In this problem also the same way. Now you have to, if you take this one as u1, first column as u1, and second column as u2 and third column as u3, then you will proceed for this problem. Take an augmented matrix with the column u1, that is 1 0 minus 2 and minus 4 3 8 and 2 5 minus 4, and then here b will add 3 minus 7 minus 3, and you will proceed like this is u2 u3 and this is b, like in the previous way. The same way you will determine for problem number 1 and 2 also. See here one more problem on linear combination only, that is for what value of h here these two vectors are a linear combination of u1 and u2. So let us work it out. So let us take, let b is equal to a1 u1 plus a2 u2. That implies we will have minus 3 minus 5 4 is equal to a1 into 1 3 minus 1 plus a2 into minus 5 minus 8 2, which implies we'll have the equations a1 minus 5 a2 is equal to minus 3, and then 3a1 minus 8a2 is equal to minus 5, and minus a1 plus 2a2 is equal to h. So this system of equations we have to solve. So we will write the augmented matrix to solve one. So consider augmented matrix AD is equal to, so this is 1 minus 5 minus 3, 3 minus 8 minus 5, then minus 1 2 h, and here, so let us mark the pivot position. This is pivot position, and then we have to make changes for R2 and R3. So for R2, these two we have to make changes. For R2, R2 minus 3 R1, and for R3 we will apply R3 plus R1. So this is transformed to, so 1 minus 5 minus 3, and R2 minus 3 R1, 3 minus 3 0, then minus 8 plus 15 is 7, and then minus 5 plus 9 is 4, and the next one is R3 plus R1, minus 1 plus 1 0, 2 minus of 2 minus 5 only, this is minus 3, and this will be h minus 3. So again let us mark the pivot positions. This is pivot position, and next this is pivot position. So let us make this minus 3 0. So which implies what are the transformations we'll apply here. The next step is for R3, 7R3 plus 3R1, R2. So this matrix is transformed to 1 minus 5 minus 3, and then 0 7 4 0, and 7 times minus 3 minus 21 plus 21 is 0, and then 7 times h minus 3, and then plus 3 times 4, so which will give me 7h minus 21 plus 12, so that will be 7h minus 9, and this is 0 here. So again let us mark the pivot positions. This is pivot position. Now we got an echelon form where you have R3 you have, so I have here R3 row, I have 0 is equal to 7h minus 9, right? Is it possible or not? Suppose if you have 0 is equal to some 7, this will be not possible at all. But I have an unknown value here h. So then what do I write? If B must be a linear combination of u1 and u2, then the system of equations must have a solution, right? That implies 0 is must be equal to 7h minus 9, which implies 7h is equal to 9, h is equal to 9 by 7. So what is your conclusion? Therefore, for h is equal to 9 by 7, B is a linear combination of u1 and u2. If h is equal to 9 by 7, what happens? 7h minus 9 will be 0 and this element value will be equal to 0. If this is 0, then this will have a solution. That is what. So if unknown value is given, then you can check whether it is possible or not. So for when h is equal to 9 by 7, then obviously it will be a linear combination when h is equal to 9 by 7. Let us see now what is a linear span. Now let me consider a set S is equal to set containing V1, V2 and so on Vp in a vector space V. Now how many linear combinations I can write with these p number of vectors? Suppose I will take some scalars a1, a2 and so on. Suppose a1, v1 plus a2, v2 plus and so on plus ap, vp. This is one linear combination. Now let me change the scalars. Suppose I take another scalars b1, v1, b2, v2 plus and so on plus bp, vp. This is also a linear combination. I will take some other scalars. Suppose I'll take another scalars. Suppose d1, v1 plus d2, v2 plus and so on dp, vp. This is also a linear combination. So what can I say? We can write infinitely many linear combinations of a given set of vectors. Now, if I take all these linear combinations, if I take a set, what is it having? It has a vector which is a linear combination of, that is, suppose let me take x1 v1 plus x2 v2 plus and so on plus xp vp such that x1, x2 and so on xp are scalars belongs to the field R. Then what do we call this set as? A linear span. Now let us see the exact definition of this. Consider a set of vectors S is equal to set containing v1, v2, v3 and so on vp. Then the set of all the possible linear combinations of vectors of S is called the linear span of S. That is, linear span of S is equal to, or you can even call it as span of S is equal to the set containing vector u. What is that vector u? It is equal to c1 v1 plus c2 v2 and so on plus cp vp such that c1 c2 and so on cp are scalars from the field F. So if you take scalars any scalar. This can be any set, infinitely many scalars you can take, so that you make linear combinations. All those linear combinations will be vector in this set, and this set is called a linear span of S. Now for example, if I take unit vectors in R2, what are unit vectors in R2? 1, 0 and 0, 1. Then take any vector in R2. Suppose I will take let u is equal to any general vector xy which belong to R2. Implies I can write this u is equal to xy is equal to, I can write it as x into 1, 0 plus y into 0, 1. Is it clear? So that is x is 0 plus 0y, which implies I can say that each u in R2 can be a linear combination of 1, 0 and 0, 1. Then I can say R2 is linear span of the set 1, 0, 0, 1. Similarly, I can say if I take R3, then this R3 is linear span of, what are unit vectors in R3? 1, 0, 0, 0, 1, 0 and 0, 0, 1. R3 is spanned by unit vectors in R3, and so on. I can say the vector space Rn is a linear span of unit vectors in Rn, n tuples or n rows column vectors Rn.